What would the periodic table look like if it was extended? So far, we've only discovered 118 elements. But are there more? 119? 150? 200? Infinite? Before we can discuss how the periodic table will continue, we must understand how elements past 118 can be created. Scientists have tried to synthesize some of the elements that we already have discovered to create the undiscovered period 8 elements. For example, in 1985, scientists bombarded Einsteinium-254 with calcium-48 to attempt to synthesize element 119, with no successful results. In 2012, scientists bombarded berkelium-249 with titanium-50, thinking that element 119 could be discovered, also without success. There have been many other attempts to synthesize elements past 118, but none have been successful, either resulting in no atoms produced or nuclear fission. Although we haven't created any of these period 8 elements, we have evidence which allows us to predict what an extended periodic table looks like. Currently, our periodic table has 4 orbital types: S, P, D, and F. However, a 5th orbital type will be introduced in the period 8, the G orbital. The G orbital precedes the F orbital and has a principal quantum number n that is 1 lower than the F orbital. The G orbital can contain a new series of 18 elements, similar to the lanthanides and actinides of the F orbital. However, the G orbital isn't the only addition to the table. If we continue going down the rows, we reach the H orbital, the I orbital, and so on, infinitely. This suggests that there is an expanding terminal in the periodic table, which houses all of the new orbitals that appear as you move further down. In row X of the extended periodic table, there would be XS, followed by the expanding terminal, which contains all orbitals after F, followed by the X-2F orbital, the X-1D orbital, and finally, the XP orbital. Each orbital type would house 4 electrons more than the previous, meaning the amount of elements in any given row would be 2 multiplied by the quantity of x plus 1 over 2 squared, where x plus 1 over 2 is rounded up to the nearest whole number. There is one final change that breaks the pattern of the extended periodic table. According to the Tokyo Institute of Technology, the 8p sublevel splits into the 8p 1/2 and 8p 3/2 orbitals by relativistic effects. This slightly alters the electron configuration of elements past 120, but does not alter previous math. So here we have it, the extended periodic table. Unfortunately, these super heavy elements are incredibly unstable, and so they may not be able to form for more than a few nanoseconds, if at all. But the concept acts as framework for future research into far edges of chemistry. Thanks for watching, like and subscribe.